Okay. Then we're going to learn integration. Right. So before that, we'll briefly go through the content standard and learning standard that you're going to cover. Right. So we're going to cover 3.1, if possible 3.2, right? So 3.1 is explain the relation between differentiation and integration. Then 3.2 indefinite integral, right? Define the indefinite integral formula inductively. Determine the indefinite integral for algebra function, and the indefinite integral for function or in the form of ax squared, ax plus b power n, and determine the equation of the curve, right? So hopefully we can cover 3.1, 3.2 today, okay? So what is the meaning, what is the relationship between differentiation and integration? So I can imagine that differentiation and integration is a brother and sister, okay? So we differentiate fx, you get f prime x, right? So if you integrate f prime x, you get fx back. So y equal to fx is the antiderivative of the function f prime x. So in the process, integration is the process of determine y equal to fx if given the derivative dy dx equal to f prime x, right? So fx is antiderivative of f prime x. So if that's mean, if I give you a gradient function dy dx, so I want to get y back, so I need to do integration on it. So let's see example 1. Okay, so if d 3x squared plus c is 6x, where c is constant, so if I integrate 6x dx, right? So I integrate 6x dx, so I will get back 3x squared plus c, okay? So because this is f prime x, right? So that means if I integrate f prime x dx, I'll get back fx. So this is fx. So this is f prime x, all right? B, if I differentiate x over x plus 1 equals to hx, then I want to find integral of 2hx dx, right? So what should I do? So if I have d x plus 1, so equals to hx, right? So this is our fx, this is our f prime x. So if I integrate hx dx, I will get back x over x plus 1, okay? So therefore, if I integrate 2hx dx, okay, so I will get back 2x over x plus 1, okay? So if I integrate hx over 3 dx, okay, so I will get back 1 over 3 hx, okay, sorry, dx. Therefore, I will get 1 over 3 x over x plus 1, okay? So if I can give you a very quick example, if I have d x squared plus x, so I will get 2x plus 1, right? So this is our hx. So if I integrate 2x plus 1 dx, I will get x squared plus x. Or this means I have hx dx, I will get back x squared plus x. So if I have asked you if I want to find 6x plus 3 dx is equivalent to 3 times 2x plus 1 dx. Therefore, I have 3x squared plus x, right? This is your answer. So you can try. If I differentiate 3x squared plus 3x, right? If I differentiate, okay, if I differentiate 3x squared plus x, so I will get back 6x plus 3, right? Same as this. So that is your answer. That's why I get if I want to integrate hx over 3 dx, I will get 1 over 3 x over x plus 1. Okay, so if given y equals to 2x squared minus x, right? And dy dx is 4x minus 6x squared. So therefore, if I ask you to find 2x minus 3x squared dx is equivalent to what? So, but we know that 4x minus 6x squared, right, dx, you'll get 2x squared, 1 minus x. So, but here, because this is 2x minus 3x squared, so it's, right, so 2x minus 3x squared dx is equivalent to 4x minus 6x squared dx over 2, okay? Right, so meaning that is 1 over 2 fx minus 6x squared dx. Therefore, our answer is 1 over 2 x squared 1 minus x. So it's x, sorry, times 2. Okay, because this, if integrate 4x minus 6x squared, you get 2x squared times 1 minus x. So we'll eventually times half, right? Half times 2x squared times 1 minus x, we'll get x squared 1 minus x. Okay, so we can try to prove it. So if I expand this one, is x squared minus x cubed. So if I differentiate x squared minus x cubed, so I will get 2x minus 3x squared. So that is our answer for this. Okay, right, so this is how you get the answer. All right, so we go to D. Okay, D. Find the value of A times B. So if D is AX plus B, so what's the value of A? B, A times B, okay? So if we differentiate, so you get 10x minus 6, okay? So A will be 10, B will be negative 6. So A times B is negative 6 times 10, so it's negative 60, okay? Okay, so it's not related to differentiation actually. Not related to integration, but differentiation. Fine, never mind. So mix up here. So let's go to E. If y equals to 1 minus 5x power 4 over 4, so and dy dx is this, okay, find the value b minus a, hence find the value of 1 over 5 dy dx when x go to 1. So it seems a bit confusing, right? So let me simplify. So y equals to power 4, okay, over 4. So I will do dy dx. So you get 4, 1 minus 5x power 3 over 4 multiply negative 5, okay? So differentiate the bracket, okay? Differentiate the bracket, and then you differentiate inside. So you get this. So you get cancel out. So you get negative 5, 1 minus 5x power 3. So if you compare to a times 1 minus 5x to power b, Therefore, A is -5, B is 3, right? So what's the B minus A? So B minus A is 3 minus -5. So you get 8. Huh? So this is E. So hence find the value of 1/5 dy dx dx. Okay. 5 dy dx. So is 1/5 delta y. Okay, so it's 1/5 delta y is y. So what is y? Okay, y is 1 minus 5x power 4 over 4. So the question asks you to find the value of 1/5 integral of dy dx dx when x equal to 1. All right, so 1/5 when x equal to 1, that means y minus 5 power 4 over 4. So you use your calculator. So it's -4 to the power of 4. Okay, divided by 4, divided by 5. Okay, so you get the answer 64/5. Okay, so this is E. Huh? So, okay, so I hope you understand. How about F? F is hx equal to x over 1 minus x squared, and dx dx is equal to kx, right? Okay, so I have d dx hx equals to kx. Okay, so if I integrate kx dx, I should get my hx back. So if I have negative kx over 4 dx, right? So if I rewrite everything, it becomes -1/4 kx dx. Okay, hence, right, hence I will get -1/4. So I use other color for f for kx dx equals to -1/4 times hx. So what is hx? Hx is x negative x over 4 times 1 minus x squared. Okay, so this is your answer. Right, so hopefully you get the answer. Right, so this is 3.1. Okay, example 2, the coal production from a coal mine is K equals to 48,000 T minus T cubed, where K is the mass of coal produced in tons and T is the time in years. So find the rate of production of coal, right, dx, in terms of T, dk dx in terms of T. Right, so dk dt, dk dt, so is 4800 minus 300 T squared, right? This is in terms of T, not dy dx, dk dx in terms of T, right? All right. So sorry, so please you edit, this is dk dt, right? If the rate of the product is given by 96,000 minus 600 square, find the mass of coal produced in the tons in the 4th year. Okay. So from here, if now dk dt is 96,000 minus 600t squared. So it's equivalent to, right? So from here. So if we integrate this, okay, 48,000 minus 300t squared dt. So you should get back k, right? K in terms of t lah. So that is 48,000 minus 100 t cubed. So now is 96,000 minus 600 t squared is actually equivalent to 2 times 4 at 1,000 minus 300 and t squared. Okay. So if we integrate this, right? So it will be 2 dk dt. So it will come 2k. So 2k will be 2 times 4 at, sorry, this one is t, sorry, minus 48000t minus 100 t cubed. Okay. So in the fourth year, so this is 2k. So this means in the fourth year, so k. So this one, remember t. K means kt lah. In the function k in terms of t. So is we have 96,000 t minus 200 t cubed. So when t is 4, so we substitute 4 in. So 96,000 times 4 minus 200 times 4 cubed. Okay, sorry. Okay, so you'll get the answer is 371,200 tons. So by the way, 1 ton is, okay, 1,000 kilogram, right? So 1 ton. So that you know that the lorries, there are 3 tons, 5 tons, 10 tons. So okay, so that is in tons, right? So okay, so please do the exercise 3.1 and page 84 and the formative exercise on page 84, right? So please do and check your answer by your, all right? So this is 3.1, right?